Clemmensen reduction. This is a kind of chemical reaction is named after Danish American chemist Eirik Christian Clemmensen. In this reaction, carbonyl compounds are reduced into respective hydrocarbon with zinc amalgam in the presence of hydrochloric acid is known as Clemmensen reduction. The conversion of a carbonyl group into methylene group is done by Clemmensen reduction. The carbonyl compounds means it's containing carbon and oxygen double bonds are referred as carbonyl compounds. Aldehydes and ketones are coming under the category of carbonyl compounds. This type of reduction always done under hydrochloric acids, and it's a base sensitive carbonyl compounds are undergo these kind of reactions. In this reaction, hydrochloric acid it gives source of proton, and amalgamated zinc it gives source of electron. Simultaneous reaction or abstraction of proton and electron by carbonyl compounds, finally it gives corresponding alkane. Here I taken its unsymmetrical carbonyl compound in the presence of hydrochloric acid and zinc amalgam. It's converted into corresponding alkane, and it's here it's produced one molecule of water. In this mechanism, following steps are involved. It's in the first step, it's a carbonyl compounds, the oxygen atom which are directly involved or bonded with the carbon atom, it's abstract the proton from the hydrochloric acid and formation of carbocation. In this, it's an electromeric effect, it's produced in a multiple bond compound. It is approached by a reagent. Here it's a reagent, it's a hydrochloric acid, it's a produce a highly electrophile, it's H plus protons. When it's abstracted by its more electron negative oxygen atom, it's a pi electron, it's in between carbon and oxygen. The pi electron it's released and transferred, it's completely towards the more electronegative oxygen atom. Now it's a carbon, it's became a carbocation. Carbon electron deficient atom, carbocation. In the second step, it's a zinc metal donates electron to carbocation, and it's a termination of carbocation reaction. It's taking place. Zinc it's provided to electrons. It's what it's do. It's abstracted by carbocation, and it's converted into carbanion. Carbanion, the electron rich atom, carbon, it's abstract the electrons, and it's became a anion, which is it's rich of electrons. In the third step, it's a protonation of carbanion. It's taking place. It's usually it's the atom or a group of atom which are rich of electron. It's abstract the proton. It's taking place here. It's a carbanion. It's abstract the proton, and it's making a bond. It's already it's two electrons are present on the carbon atom. It's abstract the proton and making a bond with the hydrogen atom. It's a protonation. It's taking place in the carbon. In the fourth step, protonation of oxygen and formation of carbocation. It's formed. It's after here it's a protonation of in the first step it's a protonation of protonation taking place in the oxygen atom, which are directly bonded to carbon atom, carbonyl oxygen. It's a protonation taking place. In the third step, protonation taking place in the carbon, which are carrying more electrons, and in the fourth step, protonation of oxygen. It's taking place in the oxygen atom. It's a formation of what? It's taking protonation. It's a comparatively carbon. It's oxygen. It's a more electronegative atom. Here it's a protonation taking place. After formation of bond with the hydrogen atom, it's oxygen, it's makes after the formation of bond formation, oxygen it's partially it's became a electropositive. Due to this, it's a bond in between the carbon and oxygen. The electron which are involved in that, it's transferred towards the electropositive atom of oxygen. After transfer of electrons, it's 1 mole of water, it's completely it's formed and it's released. After transfer of electrons, carbon it's became a carbocation. In the fifth step, it's a zinc metal, it donates 2 electron to carbocation, and formation of carbanion. Carbocation it's converted into carbanion. In the sixth step, abstraction of proton. By abstraction of proton by carbanion and formation of alkane. In this, it's a final step, it's a carbanion abstract the proton from the reagents and it's produce corresponding alkanes. Carbon valencies is 4 here, already it's 2 valence here, it's fitted, it's bonded with 2 alkyl groups, and 2 more valencies, it's bonded with 2 hydrogen atoms. So we finally we get it's a targeting product of alkane. Now we go for application of this Clemmensen reduction. Application of Clemmensen reduction, it's a reduction of usually ketones. Here I taken it's acetone and acetophenone. Acetone it's 2 symmetrical alkyl groups, its presence on both sides of ketone moiety. When it's go for Clemmensen reduction, it gives corresponding N-propane. And acetophenone, when it's go for reduction, it gives ethyl benzene. Gives ethyl benzene. These are very good for it's a production of the ethyl benzene. It's a production of helpful for production of styrene molecule, and it's acts as a solvent. And third one, it's a benzophenone. When it's go for reduction, it gives diphenyl methane. Diphenyl methane, it's acts as a fixative in pharmaceutical industries, perfume industries. And finally I taken it's a cholestane 3-one. In this, it's a cyclopentanone perhydrophenanthrene nucleus. It's a present. It's at the third position. It's a ketone group. It's a present. It's a when it's go for it's a modified Clemmensen reduction. In that, it's instead of amalgamated zinc, we use diethyl ether or acetic anhydride at a lower temperature, -10 to -15 degrees Celsius. It's reduction taking place, and it's a third portion. It's a completely changed into CH2 group, cholestane. Cholestane actually it's access a internal standard for analyzing cholesterol by gas chromatography or high performance liquid chromatography. Actually, it's an internal standard. It's a chemical substance that is added to a sample at a constant concentration to helpful for quantify the analyte. Means it's a sample that is being analyzed by gas chromatography or HPLC. So it's a most established method of deoxygenation reactions of carbonyl compounds. We synthesized by Clemmensen reduction and modified Clemmensen reductions. Thank you.